Have you ever wondered what object-oriented programming is? Or perhaps you've heard it referred to as OOP? Let's dive in. Object-oriented programming, or OOP for short, is a programming paradigm, a way of structuring and designing your code. The magic lies in its foundation: objects. Think of these objects as self-contained elements of your program, each holding its own data and code. This data, often referred to as fields, is essentially the attributes or properties of the object. For instance, if we were creating a car object, the fields could be color, model, and speed. The code, on the other hand, exists in the form of procedures or methods. These are the actions the object can perform. For our car example, the procedures might involve accelerating, braking, or honking. So in essence, object-oriented programming allows us to encapsulate data and functions into a single entity, an object. Sounds intriguing, right? Now, let's delve deeper into object-oriented programming by understanding its 4 pillars. First up is encapsulation. Think of it as a protective shell that hides the inner workings of a class from the outside world. It's like a capsule, keeping the data and methods safe and secure. Next, we have inheritance. It's all about reusability. Like inheriting traits from your parents, a class can inherit properties and methods from another class. This makes our code efficient and neat. Thirdly, we meet polymorphism, a fancy word that simply means many shapes. It allows objects to take on many forms depending on the situation. It's like being a chameleon, adapting to your surroundings as needed. Lastly, there's abstraction. It's the art of showing only what's necessary. It's like a movie trailer, giving you a glimpse without revealing the whole plot. These 4 pillars, encapsulation, inheritance, polymorphism, and abstraction, form the foundation of object-oriented programming. But how do these pillars function in the real world? Let's take a look at some examples. First up, we have encapsulation. Imagine you've got a capsule filled with different medications. Each medication has a specific role, but they're all bundled together in one easy-to-swallow package. That's encapsulation for you. In object-oriented programming, we pack related properties and methods into objects, just like how different medications are packed into a capsule. Next, let's consider inheritance. In the same way children inherit traits from their parents, in object-oriented programming, a child class can inherit properties and methods from a parent class. It's a way of reusing code and creating a hierarchy of classes. Moving on to polymorphism. Think about a person who is a parent, an employee, and a friend. They're still the same person, but they take on different roles depending on the context. Similarly, in programming, an object can take on many forms and behave differently in different contexts. Lastly, abstraction. When you drive a car, you don't need to know how the engine works or how the car was built. You just need to know how to operate it. This is abstraction. In programming, it's about hiding the complexity and showing only the necessary details to the user. So you see, these 4 pillars of object-oriented programming are not just abstract concepts, they are principles we can see and understand through everyday examples. So, what have we learned today? We've delved into the heart of object-oriented programming, exploring its 4 fundamental pillars: encapsulation, inheritance, polymorphism, and abstraction. These principles act as guideposts, shaping how we construct and interact with our digital worlds. They are essential tools in the toolbox of any aspiring coder or programmer. Remember, understanding object-oriented programming and its 4 pillars is like having a key to unlock the power of coding, so keep learning and keep coding.